Hello world! We are back here at To Code or Not to Code. I'm Eva and I'm super happy to be here today with you. And as always, I'm here with Stefan. How are you doing, Stefan?
Swimmingly. It's good to be back. And it's amazing to have listened to the slightly revamped version of our intro theme.
Yes, it's so. Yes, for those of you who don't know, we wrote this ourselves and we're super proud of it. And I can't, I actually missed this. I missed the stream, but I definitely missed the intro too as well. It makes my day. It's a nice sort of start into the evening. If you're new to the show, Stefan and I meet every other week. We've just had a break, but we're back as you've heard. But we meet every other week and code together, learn from each other, with each other. Well, maybe I learn from Stefan, but that's okay because one day the tables will turn. I swear. But
well, they do always a little bit more. There is always something to learn as well. Yes,
there is progress. There is, we haven't lost hope yet. But yeah, I'm actually super excited for this episode because I think I'll be writing my first ever source generator, which is one of the topics that Stefan is very versed in, or has a lot of experience, but I absolutely don't. So whether you are versed in source generators or not, I'm sure you'll be able to learn a thing or two on this stream here today. So thank you so much for tuning in. And but before we get into, hi Eric, so nice to see you back as well with us.
It's not only us who is back, there's a bunch of people being back. Yeah. Woohoo! For joining in. Oh, that's very kind words.
Yes.
Also, Shahab is tuning in. Thank you very much for joining.
Welcome.
We have the one and the only Toast in Training.
Toast in Training, woohoo! Thanks so much for joining.
That's still quite raw. It's still the very raw toast ingredients there.
Yeah. Toast in Training comes back every season with a new icon, and yeah, I think is that progress? Not sure. It's sort of like one extreme to the other extreme, but it's okay.
Well, it's a new season, new toast. And the special guest of our last episode is here as well. Hello, Stuart. Thanks for joining.
Hello. Oh my goodness, so nice to have everyone back as well. And I think we're going to also start this episode off with some super exciting news, right?
Yes, indeed. Yeah.
Because I guess if you've seen this show before, you'll know that Stefan gives some really good talks at some of the biggest conferences here in Europe. And I'm very proud to announce that this year I'll join him.
Oh, yes.
At the NDC Oslo. And we're going to have a little co-talk there about pattern-based C#. So obviously, if you're in Oslo at the NDC, come stop by. It's going to be epic. I'm so nervous. So nervous about live coding, and even like people have said, oh, just write it down and copy paste it. And again, if you've been a regular on this show, you know that doesn't help me at all.
Well, to be fair, we won't be doing too much copy pasting. Well, maybe as a fallback. But
I know.
We're gonna do some live coding, yeah.
Yeah, we will.
Prone to error, but that's what's all the fun about.
Exactly.
So, about the title, could you explain a little what this means?
Yeah. No, we're gonna go through a couple of patterns, I guess, in C#. And one of them that we actually haven't, I have never looked at before, but I guess as you have, because I think you're gonna familiarize all of us with it in the trivia section, is the deconstruct pattern. Yes. So let's have a little look at one of those things. There are going to be loads of patterns.
So the thing is, in the session we're not going to chat about pattern matching. That's something else. So pattern matching is where you have, for example, like is or is not. There's also type patterns. There's also list patterns by now where you can switch on something that looks like a list or some sort of collection. This is not what the C# patterns are about. The C# patterns are a certain shape that your type needs to fulfill in order to opt in to specific language features. For example, a deconstruct pattern. Let's take a look at, let's take a look at a record. So let's define a record class. Could also be a record struct, my record. And let's say that this record has int number and a string text. Perhaps I switch to, never mind. And with a record, we get a lot of members. So, well, we only write here one line of code, but we get I-equatable. I think I recently heard, I always call it I-equatable, but I recently heard I-equatable.
Equal?
I-equitable.
I-equitable.
I-equitable. I heard this, but I'm not sure if it's right.
Okay. Yep.
Oh, pronunciation. Okay.
Pronunciation. Any native speakers to help us out?
5 minutes in this and already failing.
Yeah. I think, yeah.
No, go ahead.
We're not only learning C# as a language in this stream. We're learning English and sometimes Spanish and French we've had as well. So
oh yeah, the French, yeah.
That sounds wrong.
That sounds wrong. No, it's I-equatable. I-equatable.
But
okay.
Wait. I-equate. I-equatable.
Yeah, I guess so.
Is that right? Because it's not I-equatable, right?
I don't think so, no. But I think it's because what I heard once is I-equitable. But I suppose that is equity. That is the wrong part. Yeah.
Yeah.
Sounds good too.
Thanks for your
help. So we get what we put as a parameter list. We no. I wasn't there. So we get what we put in this parameter list. We get this as backing fields, and also init only properties out of that, so that we could, we can now say my record instance. Instance equals new. Let's put in some number and some text. We're calling here the constructor. That is also generated. We get the toString overridden. So if we were to I hit F1, right line, put in this instance and run this code, we get it. Let me enter a new line here. We get it nicely formatted. Jumping back to the lowered code, we get, since we get the I-equatable interface implemented, we also get the inequality operator, the equality operator. We get the hash code overridden. We get the equals method from the object, from the base object overridden. We get the equals method that takes this type, implemented as virtual from the interface. And we also get this deconstruct method.
Nice.
And when we have this deconstruct method in the specific pattern, we can, deconstruct this type into something that looks like a value tuple. So we could say int number and string text equals to this instance. And now we deconstruct this instance into a variable of type int number and string text. We could also declare this separately and then use the number here. We could also, if we are not interested in some parts, maybe we don't care about the text, we could discard it. Well, we still need 2 parameters or 2 arguments, because this is the deconstruct method takes 2, therefore we need to have 2 here too. But we could, if we are interested in all of them, we can discard them. And well, we could also use var. We could also do var here, and then we don't need to explicitly state the types. So we could have number and text, and they're still strongly typed. We have still the int, and if we have the text, we still have the string text. Now we could just use them and print them out. Just use them as regular variables. So we have in one expression, we can get all of the backing fields out in one go, and then use them. And this is what a deconstruct pattern is about. So,
but it only works on a record at the moment.
I
mean, it only comes with a record out of the box.
Yes. But what about? Oops! I again hit the form. What about our custom type? Let's say, well, I don't like primary constructors all too much, but let's use it here because it's super convenient. Let's do a string text and an int number. And what we can now say is we can now build our deconstruct method. So we currently see this no longer works, and the compiler gives us a hint. My record does not contain a definition for deconstruct and no accessible extension method. So there is 2 ways how to solve this. Now, a deconstruct method is a void returning method that is called deconstruct. Needs to match exactly that name, case sensitively. And now, depending on how many arguments that we want to deconstruct here, this is how many parameters we need to put there. So we could now say, as we do this as an out, this is what the pattern demands, because we are passing this location in and then have it filled by this method. So we can say out int number and out string text. And then in the body of the method, we just need to assign these. So number will become this.number, and text will become this.text. And this doesn't work with the, maybe I also need to define them. I'm rarely using the primary constructor. So I may have made a mistake there. Maybe let's be more precise, not giving them underscores at names. Does it work now?
Could you also write this dot?
Oh, yeah, I made a mistake here. I'm assigning text to number. That's not the correct type.
Oh, I should have seen that. Yep. Okay.
So now we have our void deconstruct method that has 2 outs. And then we just do this outs. We just assign our fields to. And now we again have the very same behavior. So it's nothing that only works for records. It works with any type that fulfills this pattern. And we could also have, we can also overload this. So we could have another one that maybe now takes 3. Let's say text 1 and text 2. And let's say text 2 also equals text. Yeah.
Okay.
Just for the example.
Yep.
And here no semicolon, column. There we go. And now, well, if we only have 2 arguments here, we of course only call into this one that takes 2. If we were defining 3, we would have the 3. So let's say text 2 here, and now we call into. We also see the arrows here. We call into this one.
Yeah.
Or we could also have here as a discard, we would still call into the third one, into the one that has 3, because the number, it's a number in the types that are significant.
I guess I have a question from the chat about the order.
Does the order matter when deconstructing? Yes, it does. So if I were to, let's assume this one, where we have int number and string text. If I were to turn this around with string text and int number, there is no oops, I need to get rid of the var here. There is no deconstructor that takes an out string and an out int. But I could overload it. I could now have an additional overload. So just copying this one. And all I do is now just exchanging these. So having the out text, the out string text first, and the out int number last. Maybe I add a console dot write line here. Hello. To show that this is. Oh no, this doesn't work. I thought it would.
Oh.
I thought it was okay. I thought it was also overloadable by order. No, it's not. We can only overload by number. The call is ambiguous between the followings: out int string and out string.
Okay,
int.
but if we get rid of one deconstructor, then it won't be ambiguous anymore. But yeah,
that is correct. Yeah,
I
thought we could. So we can only overload by number of out arguments. But the order is significant.
Nice.
I need to put it in the correct order in order for it to work.
Well said. Awesome.
Okay. And we could also, let's say we don't own this type. What if we can't have this in our type?
Extension method.
Also, yes, indeed. So we could have a public static class, my extensions. This is now public static void returning with the same name deconstruct, where the first argument or the first parameter now is the receiver type. So of the type that we are extending, like this, my record, I call this receiver since it's the receiver type. And then we have the out int number and the out string text. And in the body, I'll just assign something to it, let's say, because those fields here are private. Well, now doing something bad, making them, well, internal is still okay-ish in some corner cases, but doing here something that could be something bad, but just to make them accessible, so we can say receiver dot number and assigning the text to receiver underscore text so that those fields are accessible. And now, although this my record doesn't have the deconstruct method, we can, or if we wouldn't own this type, we could still extend, for example, types that from the BCL that we don't own.
Yeah.
To have that deconstruct too. So we could do something funny, like we could deconstruct a range into two indices. Index. Sorry, I'm now switching to a different version because there is a little bug here. Which one is the one that's working?
The 12, I think.
Can you remember?
C# 12.
Let's use this one. Index, what's the stat? Start and index end. And we could then say, let's call this range, and we say the start is range.start. And the end is range.end. And now we could write something like index start, index end, 5 range 10, I think. I was hoping. So that doesn't decompile here, but if we put them to the console, we could now deconstruct this range.
Yeah.
Where a system.range consists of two indices, the start and the end,
Mm-hmm.
where this is the start and this is the end, and we deconstruct these into these indices, and now we can just use them here and there.
Nice.
And that's the deconstruct pattern. And it really must have this name. If I would call this deconstruct with a lowercase d, it wouldn't work. Or an underscore at the end, it must exactly match the name. And it must be void returning. If it was to return an int, it wouldn't work either.
And public, or is that?
I'm not sure if it must be public. I think it must be accessible. So if it's within the same assembly, it would still work, because the compiler then needs to call it. If we go into the decompiled source, then we see the compiler is just calling into this deconstruct method. So it must be accessible from the location of usage.
Yep.
So if this was internal or private in a different assembly, then it wouldn't work. It must be accessible.
Nice.
Another question. So when we're using records, that means that the order is in this. I guess this order in the deconstructor is the same order as in the constructor. Where is it visible where the order is? No constructor. We have just init only properties. So for the record, I'm not turning this into a
for the record
again. For the record. Int number and string text, then yes, indeed. So it's the order, like the order of the members we define here in this argument list of this record defines the order in both the constructor, but also in the, there is some nullable properties, but also in the deconstructor. And well, we could add an additional constructor like public my record. Well, technically we could add an empty constructor. So we could now create an instance, an empty instance, where we maybe, so these don't exist, yeah. Where we now, since those the properties on the, excuse me, where do I have a compiler error? Yes, any constructor must call this constructor of this record. So perhaps we say number is 0 and string is empty string. Something like that. And since those properties that get generated, those are init only properties, so we could like also initialize them like so. Number is 999. But since it's init only, we cannot initialize it outside of the initializer. Afterwards, we can't initialize it anymore. This is an error. Init only cannot be initialized outside of the object initializer. So with a record, we always have at least the constructor that we define here in this parameter list. We could also be empty. Then we at least have a parameterless constructor, and then could define other constructors. And so on. Now this, of course, doesn't exist because this one is currently empty. So something like that. Of course, we don't have a number here anymore, but yeah. So this is that's the pattern.
Awesome. And if you use a record, right, you get all of this kind of auto-generated in the back. And what we could do now is write the same for our own type, right? No.
Yes, so we can define our own. Now let's add some fields again, some properties, int number. just remove the usage because it doesn't compile. And need to pass in a number. Just remove this one as well. Now we just have an int number. And so we get a deconstructor that only takes an int number. And if we were to insert a string text before, now we only get a single one that has the text, and again, in the same order, text and number. So we could add it to our types if we want, but it's quite manual.
And how could you automate that?
For source generator. So would you like to write a source generator that automatically generates a deconstructor?
Yes, I would love to do that. I've just never done this before, like at all. So this is first try, but it's okay because I've got my Stefan GPT.
Hey, I'm not an AI assistant, just an
AI assistant.
assistant.
You're a you assistant. Okay, well, where would we start? Oh, you already have a solution.
So what we did as a preparation is because Writer has a source generator template out of the box. So we created a new solution, selected Roslyn, selected .NET 9, selected source generators. And this was step 1. Step 2 that we took is we updated all of the packages, since there were some Roslyn packages, because the cool thing about Roslyn is it's just a library. So you can consume your Roslyn, your compiler, anywhere. Like for example, what we built here now is a plugin that you can use from within the project. We could also host Roslyn. Well, Writer is hosting Roslyn, Visual Studio is hosting Roslyn. The tool that we built the last 2 seasons is hosting Roslyn. That's pretty cool. But we upgraded this to the latest version, and we immediately get a problem. Because there is
I haven't even done anything.
Not done anything, but we already have because this project ships with 2 examples. It ships with an iSource generator.
Yep.
And an incremental generator. The difference is the iSource generator, that was the older version. I think that shipped with the .NET 5 SDK, if I'm not mistaken. I may be wrong here. And then with the .NET 6 SDK, we got incremental generators. There is not really a functionality difference. Well, at the beginning, there was no functionality difference, since incremental generators are now the way to go, the more modern way. They now have more features than the source generators because they are no longer maintained. But also the source generators, they have a potential measurable performance problem, depending on your project, depending on your setup, and therefore they are considered obsolete. So there is now an analyzer saying, don't use the non-incremental source generator anymore. So I'll just go ahead and delete from the sample the source generator example. We shouldn't use that anymore. We should only use the incremental generator. And maybe let's start afresh. Let's create our deconstructor generator. And just basically copying over the the shape of it. We need this type needs to be attributed with the generator attribute, so that whoever is hosting our Roslyn plugin, because we are basically writing a compiler plugin that can now be consumed by any application that is hosting source generators, is hosting Roslyns, like the .NET SDK will be consuming them, or Writer will be consuming them. So we are attributing it with this attribute so that the tools can find them. Basically find the types that have this attribute and then consider them to be generators. And we also need to implement the interface incremental generator. The rest, let's just get rid of. And with the incremental generator, we need to implement a single method, the initialize method, but we will again go from there. I also like to make my type sealed. We get yet another warning. We get those warnings because not only do we consume Microsoft Code on C#, this is the basically the Roslyn package that we need. We also consume Microsoft Code Analysis.analyzers, which is a set of analyzers that produce warnings and errors for us in order to guide us to write source generators and other Roslyn plugins like analyzers, suppressors, refactorings, code fixes, and all of that correctly. And we already get a hint that says to reference to should not be implemented in assembly containing a reference to. It basically says that we shouldn't have these workspaces.
Okay.
So let's just remove them. Yeah, we don't need the workspaces API.
Okay.
We really only need the C#
yeah.
Roslyn base API. The workspaces API you need in order to access and in order to modify syntax trees. You need that for a code fixer or a refactoring. So something when you hit Alt-Enter in your IDE, this then when you invoke the workspace APIs. But since we are not having any Alt-Enter mutation kind of on, we're not changing syntax trees, so we don't need the workspaces APIs. Cool. Now we don't have any warnings anymore, just a typo here, but okay, cool. So
all right.
The next part?
Next part is obviously writing a test. Isn't it?
Yes, excellent. Yeah, of course it is. It has to be.
We love test-driven development here on the stream, so let's do it.
Especially with source generators, since it's a little bit indirect, because you are not running the source generator directly. You will have your host, which is hosting this Roslyn component, will be running generators, and this could be the .NET SDK, this could be wider. So it's a little bit indirect. So having a test is absolutely helpful, and also helps with debugging. We can then just do a breakpoint, run the test, and do some debugging. This will be incredibly helpful. Let's actually, I'll just copy one thing over that I don't copy anything over. Just get rid of that. Oh, this is from the workspace APIs. That's also not gonna need that. So let's define our first test. We have XUnit here installed, so we're gonna have a fact. Not sure about the name, so let's start with to do. Oops. Oh, I wrote taught. So in this,
is this a foreshadowing?
Yeah, I hope not. So in this test project, we not only consume XUnit, we also take a dependency on Microsoft Code Analysis C# source generators.testing.
Nice.
Which is a package from Microsoft that, facilitates testing of Roslyn components. In this case, source generators. And we can jump to the documentation. There is multiple packages. There's also packages for analyzers, for code fixers, for code refactorings, and also source generators. This is the package that we are consuming. By the way, this also exists for Visual Basic, because those components also work for Visual Basic, and C# are both part of the Roslyn compiler. And in the documentation, I'll be just briefly copying this over, because this is a specific type that we need as a bit of an entry point.
Okay.
So we're gonna have our C# source generator test.
Yep.
This C# source generator test needs the type of the generator and also some verifier. For the verifier, we can just use the default verifier, and our generator will be our deconstructor generator. Let's import it. And now we should be able to say new verify. And in here, now initialize our test state. So what will be passed in to this Roslyn toolchain, because under the hood, this will then find our generator, will invoke our generator, and then compare the generated source code against our expectations. So in the test state, we will have some sources. This will be our input sources. So this is just some
kind of
C# text.
Yeah. Kind of what you need to code in order to invoke our generator.
Exactly. This will be the user code.
Yep. Got it.
And also we should have generated sources. Oops, this is in the test state, my bad. Also generated sources, which is now going to be the output. If I remember correctly, those generated sources, they have a type of the generator. And then 2 strings, if I get that correct. Now I may have made a mistake. Source file collection. Oh no, it only allows. Okay, we have a file name and the actual text. There we go. But can we do this different? Maybe do this differently. Maybe we say verify.teststate.generatedSources.add. And then in here, we can now say what I wanted to say, type of our generator with what we can add here, because there is the add method that takes this tuple and has a type, a file name, and the content as a string. And well, this needs to be a tuple. And why does this not work? Cannot resolve method. What am I doing wrong? We have here this collection. We can say add, and this takes a tuple of type, string, and string. Not sure. What am I doing wrong?
Not sure.
String text. Okay, that's embarrassing. Candidates are type.
Yep.
This is exactly what I'm looking at now.
Yep.
That's the add method. It has a single argument, single parameter. It takes the type.
Yep.
String and string.
Yep. And this file thing at the end, is that something?
That's then the name of this tuple, because here's this states a tuple.
Do we have a name?
Source file collection, which is a list of. Okay, not sure what I'm doing wrong. Maybe if we just do the add, if without the type, would that work? No. I'm totally uncertain what we're doing wrong here, but I'll look that up in the meantime.
Okay. Yes.
So perhaps let's start with, let's say, string expected or generated. And this then should be the generated output. Yeah, I guess this usually starts with auto-generated or something. So would you mind now starting with the user code? What the user should write as an input in order to trigger the generator.
User code. Yes. So, oh my goodness, do we need, if we're writing code, do we need the raw string literal?
We don't need it, but it's super, super helpful.
Okay, I need it. Oh my goodness. How do it? 1, 2, 3. Is this enough?
Yeah.
Could be. Nice. All right. So, right. Well, we're going to have our own type, right, that we want to have this generation for. So I can start with like a public class, coding stream, and this can have some fields, right? Like the public. This doesn't look nice. Oh, okay.
Yeah, don't mind about the formatting too much.
Host name. Is this okay? Should I have a get and set as well? Or is this okay?
Maybe let's start with,
I did it wrong.
do we want to do it on properties or do we want to do it on fields?
Oh, good question. I don't know.
Whatever you prefer. We could later and then also do both, but let's start with one.
Okay. I don't know. So we can start with, this is now a property.
Yep.
No. Yes. Oh God. Using the correct words is tricky for me. And we can have another one, namely also maybe a string topic.
Okay.
Right? And then, but this is like, this wouldn't have this deconstruction option unless we tell it to somehow use our source generator with an attribute, right?
Yeah, this is usually a common pattern to not just generate stuff, but to place an attribute to instruct the generator for this type now generate this, because maybe it's very likely we're gonna need for each and every type, so it would be total overkill. So it's a common pattern that you place a specific attribute where you want some generator to generate something. Then this attribute, we could also give some data to the generator, maybe some information. Hey, use only the fields, use only the properties or whatever, to pass more or less data to the generator. But yeah, I mean, we could do it for every type that we find in our compilation, but it's usually common you do it only for specific types. And you then tell this via an attribute.
Okay. So we want an attribute. And does this also have a naming thing? Suggestion?
We could
AI
go
assistant,
something with,
give me some naming suggestions.
We could go with something like, let's see, I would now check some existing patterns. For example, there is a source generator for regex. I'm wondering how they call this attribute. Source generation, for example, this is how the generator for source generator for regex works. There is a generated regex attribute. So we could call ours generated deconstructor or generated deconstruct.
Deconstruct. Nice.
Cool.
Okay.
We want this type.
I love it. And I even duplicated it. Good start. String. Okay. Let's copy paste. It's not. Oh my goodness. Okay. Done.
Cool. And what should then the generated output be? Usually it's good practice to start with the auto-generated comment in order to indicate, well, this is a generated document. In generated documents, the default nullability is disabled. So it's also good practice to, that is very good there, auto-completion, to enable nullability there as well. And having these two on top, that's common patterns for generated source code. So what would you now expect the source generator to generate?
I'm tempted to look into SharpLab and see. No. That's
a very fair point. Let's do exactly that. So let's go into SharpLab and let's create, we still have the record there. We have two strings, right?
Yeah.
So I'm just gonna now copy the deconstruct.
Yeah.
we get a compiler generated attribute here. Well, we can't use that, but there is a different attribute we could use. I'm going to replace this in just a second. Yes, and now we just need to fix the names here to match our pattern.
Yes, host name, topic. Woohoo!
Both strings. Guess we also need to do that here. Host name, and
topic.
Cool.
Easy.
So we're not going to use compile generated because it's generated by a source generator. There is another attribute that I need to look up now. C# generated code attribute. That's somewhere in the code DOM namespace. I always forget about it. Generate code attribute. There we go. So that's a generated code that's in the system code DOM compiler.
Yep.
What's also good practice in generated code is not to have usings, because they could technically clash with other usings. It's good practice to refer to types, to full types, via the global namespace alias. So it's practice. Whenever you have a type, you say global : :
Yeah.
and then the fully qualified name. So the namespace.
Okay.
And where is it? Code attribute. Now this is constructed a string, where the first string is the tool. Well, our tool, this would be, we could call this our generators. And I like the auto completion of write already.
Yeah. Awesome.
It's the tool name and then our version 1.
Perfect.
Sweet. I'm just gonna fix some spacing here.
Yes.
They may bite us later on. Now, what I see here, this is quite invalid, because we just have a method here, which doesn't, this is like a top level method. We can only use this in top level statements.
Okay.
But if the user has them already, this won't work. So we need to, this method needs to live in a type. Particularly, it needs to live in this type. So we need to wrap this deconstruct method in that type. Just gonna briefly do that. So we will have this type.
Or we could do an extension. No, we can't.
We could also do an extension. Yes, we could also do an extension. But perhaps let's start with the with a member. But what we now have a bit of a problem, because now we declare the same type twice. Do you know what we need to do in order to merge them? So we have two different
partial.
Exactly.
Ha! See? Progress. If you're interested in the topic, partial classes, we did talk about it last year at some point. I can't remember the episode though. But you can view all our episodes on our YouTube channel. We need a commercial break jingle as well.
So I'm not trying to compile this in my head. I may be missing something. Well, this attribute will also live in some namespace. So in the user generated code, we could be using a using, and well, this could live, for example, in the our generators namespace.
Yeah.
And this should be, we're using string that's always available. This should be good to go. That if we have a typo here. Now, the source text, this does not because what I'm trying to find out still, how to add this to the generated file. So source file collection is a list of this tuple string and source text. So maybe let's quite use this one. Source text lives since Microsoft Color.text. Let's see if we use that and introduce. Not sure why the using is not. Can I resolve source text? That Why not? We should have the package for it through. Oh no, we don't. Do we? We don't. Okay, so perhaps we also need to refer to this package. I'm wondering why we don't get this as a transitive dependency. Not sure, but if we add that, that should resolve. Maybe that was the problem all along.
Oof.
Yeah, apparently that was the problem all along. I'm surprised that we don't get this because we are consuming our generators, and why we don't get this as a transitive dependency.
Good question.
Maybe because this is marked as an is-wasling component. Perhaps. Could be. Because, it could be. I'm not entirely certain, because what's also good practice is if we were to publish this as a NuGet package, our generator, now, well, this is private assets.
Yep.
That means this won't be a transitive dependency for the consumer, but this would be. Now I can imagine, I'm not entirely certain, I'm guessing a little bit here, that this wasn't component is suppressing this, but what we could also do is to mark this, or we could also do it just like so, where we say private assets all, so that if we publish this as a NuGet package, that the consumer doesn't have a dependency on this, because our generator really is just a compiler. It's really a compile time dependency.
Yeah.
At one time, our wasling components shouldn't have any impact anymore. So there shouldn't be a one-time dependency, only a compile time dependency. And I'm not entirely certain, but perhaps this is what this is doing, and why we needed now in our test project to explicitly state this dependency, because it wasn't transitively flowing. I'm guessing though here, but could be. So cool. Now let's put in the generated into here. I guess now we can also use the type of this generator. So we have type of, let's do a new line here, type of our generator, our deconstructor generator. We have a file name and our generated code. And the generated code is a string, so we here need to say, well, I guess we should be able to have string here as well. Cool. Now we can add this here. Actually, let's do this in a single line. Clean this up a little bit.
Nice.
Okay. We'll come to the file name here a little bit later to do what this means.
Okay.
But now we have a test that we can run. Let's see if we have our first failing test.
Oh,
it succeeds because we're not verifying anything.
Oh, we're not. Okay, fair enough.
Verify dot, is it verify? One async. So we need to await this. So we turn our test into an asynchronous method. Now this should be a failing test. And indeed, because we expected a source file. Verifying source generated files, expected source file list to match. But here's a minus. So we expected to have our to-do file here. This is the name that we entered here. Maybe let's call it todo.g.cs in order to indicate. Maybe let's talk about this right now. So this is not necessarily a file name.
Yeah.
This is not, well, it's called file name here in this generator sources type, but it's not necessarily a file name, because if we generate, source generator generates code only intermediately. It doesn't necessarily exist as a file somewhere physically. There is a compiler flag that you can set in order to generate it as a file as well, but it's usually not really existing as a file, but it's more of a hint name. And this hint name, well, could be used in order to generate a file if you set the correct MS build flags. Or it could also show in your IDE, could show you, hey, this file was generated, and then give it that hint name. So tooling could utilize this file in order to or this hint name in order to display it, although it's not necessarily a physical file. And we could give now, because we would generate a new document per type that we attribute with this. So we would use the full name of this type, which in our case only coding stream. Maybe let's also put this into a namespace.
Oh yeah.
Our namespace.
Yep.
So this would be now, the full name would now be, let's say, string hint name. Our namespace dot name of the type coding stream dot deconstruct dot g.cs. Again, the g.cs, we indicate that this is a generated document. Again, good practice. And now this test would make a little bit more sense, because we see that we expected this g.cs to be generated, but it wasn't. Well, because we haven't generated anything. So we have a failing test, and now it's time to implement our generator.
But so sorry, one more question. It only verifies whether or not a file has been generated, not whether or not the generation was what we wanted it to be?
In the first step. In the first step, it checks,
okay.
We expect one generated source.
Yeah.
I comment this out. Now the test should pass, because we don't expect anything to be generated. Okay, but we have some diagnostics. The type or namespace our generators could not be found. Are you missing a using directives? Okay, we have a problem, because this namespace, because we still want to generate this attribute from this namespace, which it wasn't. Which actually, we forgot that we also need to assert that we also want to emit this attribute in our generator. So yeah, currently we don't expect anything, therefore there is nothing. Now if we expect, it first asserts, is there the exact name of documents generated? And if it is, then it goes into the documents and checks, are they exact string matches?
That's really cool.
And what we also want to generate is this attribute. Technically, this attribute, if we have an attribute that is a trigger for a source generator, this shouldn't be really emitted by a generator. You may want to have a separate library where you contain this attribute. Okay. Because if you have, let's say, 100 projects that all have this generator, now all of these generators would emit this type. We're not having it once shared so that every project can reuse the same type. But this may also be a little bit, again, of an optimization. But when it comes to generators, then optimization is very
key.
Welcome.
Oh, okay.
But in this episode, we're going to do everything with source generators. So we're going to show what you could do. Well, if it's a more of an internal project that you use, where you know the scope and it's maybe only used within one project, then that's perfectly fine. If you maybe publish this to NuGet and the world is your consumer, then you may want to think about different means of transporting this attribute. So let's now generate this attribute too, which is also generated code. So let's have here our kind of a preamble here. This will be in the namespace, our, what do you call it? Our generators.
Yep.
So we're going to have gonna make it internal. So it's only visible to this compilation. Internal sealed class, how do we call it? Generated deconstruct attribute, colon attribute. And this is basically the type that we need. We could later on also add some arguments to this attribute to have like information like, hey, only use it for fields, only for properties, any member that you find, kind of a thing.
Yep.
And now we also want to expect this attribute to be generated as well. The hint name of this attribute would be, maybe let's also see again the full name, our generators.generated deconstruction attribute.g.cs. And the expected source code is this attribute. And now we actually expect two files to be generated. This attribute.
Yep.
And the code that we have attributed with. And we see,
fail at both.
Which actually we could do another test where we say in the first test we don't attribute it and then only expect the attribute to be generated, but nothing more. So that our generator really only is triggering when we indeed have something to be generated. So not attributed.
But so if we don't want anything to change in the second test, then why is the attribute still generated? That's always generated.
The attribute that we generate unconditionally.
Oh, okay.
That's always generated, yes.
Nice. Got it.
For this example.
Yeah.
Cool. Now, I guess the first step is how do we unconditionally create this attribute? Now there's multiple phases. Oops. Multiple phases. Multiple phases with a generator.
Yep.
We first have the initialization phase.
Yep.
And then we have the generation phase. The initialization phase is usually triggered once. And in this initialization phase, you can also have a so-called post-initialization. So when our generator is loaded, well, it's initialized.
Oh.
And after it has been fully initialized, we can also have a hook into the post-initialization where we can unconditionally generate some sources, where we do not have the context of the user code just yet. So we do not see in this post-initialization phase, we do not see this partial type. Is what I mean with unconditionally. In the later phase, we can conditionally generate some code. For example, now we see the user code where we can actually see, okay, we have this type with this attribute, so let's generate some code for that. So it would be the post-initialization where we could emit unconditionally this attribute. Everything is done via this context. This context has all the code we need in order to initialize our generator. And we can register something for the post-initialization. Now, this post-initialization is an action that takes an incremental generator post-initialization context.
Wow. Wow. I think that might be my word of the year.
One could say it's a very descriptive name.
Yep.
So we have our context here.
Yep.
And now we can just writing this action here, and now we can use this context to add some source code. And now this add source method takes two strings, the hint name, and the actual source code that we want to emit. Now it's important to match.
Whatever we wrote in the text.
In Waslin, we could do Visual Basic or C#. Per default, the generator, if you take a look at the generator attribute, per default, this is for the language C#.
Nice.
If we were to write language Visual Basic, we could also have a Visual Basic generator. We could also have a generator that has C# as a first language, but also does Visual Basic as an additional language. Super rare, but yeah, just noting that we need to be careful what we emit. We also need to be careful about the language version that the consuming project is using. Because maybe our consumer, where we consume this generator, is using C#1. But if we emit now an attribute that is using file scope namespaces, which is, I think, C#10, this would fail. So there's a lot to consider when it comes to building a generator. But yeah, well, for now we assume all is C#13 and all is there.
All is well.
So I now want you to basically put the hint name here.
Yep.
And the source of this attribute. You may
Okay, but
perfectly
we are
copy paste from the test.
We're still in a post-initialization phase, which means we would just want the attribute.
Yes.
Yeah. Got it. Ooh.
Yep. Thorsten Trading is asking, are we getting Java style names? Are those very verbose names? Oh, I don't want to say verbose. Descriptive names. I haven't written Java in quite some time, I have to admit.
I'm just copy pasting in my own.
No, you're sure.
Yeah. No, wait, I did it wrong.
Perhaps you want to do a triple warstring literal.
Yep.
Before warstring literals, writing source generators and test for source generators was a little bit, or in general, writing tests for warstring was rather painful. Incremental warstring literals are amazing. Cool. Let's give that a try. If one of our tests is now, passing.
Oh yeah, true.
No, it's not. Why is that not attributed? Because we still have one diagnostic. The typo namespace attribute could not be found. Ooh, yes. Sorry, my mistake. We don't have any using.
Yep.
And I said that in generated code, we always want to do this aliasing via the global namespace alias. So we should have global colon system dot attribute.
Okay.
Likewise, since this is a generated attribute, we also want to put our generated code hint here. So this is also generated code from our generator in this version. I'll not update the production code so that we see an error here to show. Now we see, okay, there is now a difference.
Yeah, I already added the global. Sorry.
It's all cool. It's all cool. I run the test before, and this is really cool. In this testing project, we see the actual and the expected here with this plus, minus, and plus, very similar to a git to the git diff syntax with minus and pluses. Well, I guess in general that's a diff syntax. And if the line is the same as expected at actual, then it will have neither a plus nor a minus.
Cool.
And now, yeah.
Well, I didn't save. I did save, but maybe it didn't work.
Perhaps I need to build.
And then still need the one. I didn't do all the changes as well.
Not sure if, because we do have a fading project here, some examples project. I'll just get rid of these examples. Maybe that's related. Ah, yes. Now we need to update
the thing.
Mm-hmm.
Is that it? Oops. Is that right?
Let's give it a try. And so we're still missing it lags a little bit behind, right? But we actually added it. So oh, my bad. Yes, my bad. I only edited one test, but I edited the wrong test because we have this here again. Maybe we actually moved it since, I see a duplication. Maybe let's move this out, this attribute. Maybe let's move this out to a private static read-only string attribute. Let's have it here once. And then reuse it everywhere.
Forever.
Yeah, that was my problem, was using, test was right, but I didn't edit the test correctly. And now the test passes.
Woohoo!
So if nothing is attributed,
Nice.
all is good. But if something is attributed, so
And-
the attribute is still generated, but the deconstruct document is missing.
Okay. So
Now
we
it
need to go
comes-
into the generation phase.
Yes. And now this is a little bit indirect. So what we do now in this, because here we have an initialize. If we would take a look at the I source generator, the I source generator actually has two interfaces. It has initialization.
Yep.
In the initialize, you will also see something like post initialization. If I see post, there it is, very similar.
Yep.
But where we create the actual sources is in the execute phase.
Oh.
And in the execute phase, we now have the add source method here. But in the newer I incremental generator, we don't have the execute phase.
Okay.
Because we don't write this. It will at the end, we will then see what this how this performance difference is achieved, or what is the benefit of doing it this way. Is we don't do it execute directly, but indirectly. We will build now a pipeline of our generators.
Okay.
So we will have a pipeline of various steps that then will run whenever the host decides to run our code. In our case, for example, when we run our test, or when we consume the generator in a production project, then actually potentially on every key press.
Okay.
So it could be that whenever we press a key, the generator is executed. This is where performance is critical, because this generator during development time may be executed a lot. And via this indirection, if we build up a pipeline with various steps, between these steps, the generator engine, the so-called driver, the generator driver can do some shortcuts. If it sees between step 1 and step 2, nothing has changed, then it can skip all the rest and just reuse the same results again in order to do some short-circuiting. And that's the problem of the older model. The older model doesn't have this indirection, so it's always executed. And this will make sense then, or it will be more visual then at the end. So now let's come into building up our pipeline. When we come to a pipeline, now is the question, where do we start?
Yep.
We have providers.
Yep.
There's a syntax provider, a parse options provider, a metadata reference provider, a compilation provider, an analyzer config options provider, an additional text provider. For example, additional text provider, if we were to have a generator that reads maybe XML documents that we have attached in our C# project, it could read those additional texts and create C# code out of them. For example, we could have a compilation provider that analyzes the compilation options, such as the .NET. What's that? No, I'm not sure whether this project is a library or an executable, I think. We could also take a look at the parse options. The parse options contain information with which language version was this project parsed. And the syntax provider, well, this would be the provider for the syntax. So we could inspect via the syntax provider, we could inspect the syntax of the user code. The syntax provider now also has in another method. So the create, I know it's a little bit complicated. We're not going through all of that because that kind of would be too much. The older way was that we create a syntax provider, where the syntax provider now has two phases. A syntactic match, where we get in each and every syntax node of the user code. And if we perhaps take a look, maybe let's get our text here, and I'm putting this into SharpLab. Doesn't compile because of this attribute. Let's get rid of the attribute.
Oh, wow.
What else am I doing wrong? The type of names with our generators is not found. So yes, using, there we go. And oops, we have a warning. So let me just put some exclamation marks here. Okay. So we would get in each and every node. If we change it to the syntax tree, we would get in each and every node of the user code. So we could, for example, well, since we are searching for an attribute here, we could, for example, generated attribute something. No, that wasn't generated. What do we call it? Generated deconstruct.
Yep.
We could find that syntactically. For example, this attribute. That's a little bit tricky because we could also have an alias. We could have using other name equals to this generated code attribute and then use other name here. So it syntactically doesn't look like the attribute we're looking for, but semantically it does. And yeah, we see there is when it comes to finding these attributes, there is a bit of there's a lot to consider. And for each and every step of this, of the nodes, we would then return true if we are interested in this node. So this is a syntactic filter because syntax nodes, those are syntactic, and we check all of the syntaxes and are we interested in them, yes or no.
Okay.
And then for each and every one of them where we are interested, we now go into a transform phase.
Aha, nice.
In a transform phase, so you can think of this predicate, you can think of a select, you can think of a where, actually as a where, and this would be the select.
Oh, okay, yep.
Very similar. And in the select, that's a transform, and we can now change our syntax node. We now have the semantic model at our hand. And with the semantic model, we could ask, for example, now this name, hey, this syntax other name, what is the actual semantic type for this? And since it's just an alias, we get the actual semantic type.
But sorry, and we can do this in the where do we do this? In the transform phase. Okay.
So we could in the syntactic phase find all of these attributes.
Yeah. That we're interested in.
Yes, and then return true if we find an attribute. And then in the transform phase, ask, is it really this attribute?
Okay, so we get all attributes, and then we check, is it our attribute? Got it.
Yes. So this is how we could do it. There is, of course, many ways that leads to Rome, if this is also an English expression. This is one way we could do it. But this pattern of attributing types with attributes is so common that in newer versions of the incremental generators, there is now a for attribute with metadata name.
Love it.
And this does a lot for us already, where we just state the fully qualified metadata name, which means this is the actual name of the attribute, well, in metadata, which is the fully qualified name. So in our case, we are now looking for this, our generators dot this attribute name. If this was in later versions of C#, we can also have generic attributes. I'm not sure, is the C# 11, 12, something? If you would have a generic attribute, this metadata name would be with this backtick 1. Perhaps you have seen this sometime in some type names. When you have generic types in metadata name, they have this backtick name. That is, 1 stands for one generic type argument. If we had 2, let's say T1 and T2, this would be a backtick 2. So this is really the name, how it looks in metadata. That is, if we would look at it via reflection. But we don't have a generic attribute, so we don't need that. And the rest is very similar. We then again have a function that has this predicate function and a transform. And in here we would now do some checks and some transformations. So our first one would be, we need the cancellation token. So we have the node, the token, Boolean is the return value. Just returning true here now for now, or let's say false. And what I'm doing wrong, I need the lambda here. And comma. And the second one is the transform. Which now returns something. We still need to define that. I'm just returning an object for now. And we have our context and again our token, and we will go to our implementation. And I believe there was somewhere, let's return null here. Cool. And yeah, so what we want to do now here, do we want to do any syntactic filtering?
Yeah.
Actually, I'm not so sure anymore what we get in here. I don't think, because I think we get for attributive metadata name, I think we get, if we get the symbol that this is attributed with, or if we get the attribute itself. Let's see if documentation says something. That's the target. So what we should get is, in our case, just remove that this error disappears. In our case, we should get this class declaration. What we may want to do syntactically, we could check, does this class declaration have the partial keyword? Because if this is not partial, we can't really create anything.
Oh.
This needs to be partial. So we could do in the syntactic filter, check if this type has the partial keyword. So let's check that. So let's only return true if this node that we have has the syntactic keyword.
Node.
And this node would be or we assume this node is a class declaration. So perhaps let's do a check first if this node is indeed a class declaration syntax.
Node. Class declaration? No.
No. Just with pattern matching, just what is.
Is.
And then the type that we want to search for, there should be something like class declaration.
Declaration syntax, easy.
And if it's that, then we can ask it, do you also have the partial keyword? I'm not sure how this looks like. Is there something like, let's see what we have on node. This may be a modifier, but I'm not entirely certain anymore. Is there something like is partial or something?
Is no.
No. Then I think that's a modifier. So we need to check if the modifier contains partial.
Modifier? No.
Does it have modifiers?
No.
What does it have? Does it have not modifiers? How are they called? Also, wait a minute. We are on the node.
Yeah.
Since we check here, we actually, because this node is still of type syntax node.
Yeah.
We want this to be a class node, a class declaration. So what we could now with this pattern matching here, this is not actually pattern matching. We could maybe call this C here. And if we use this C instead here, now we should have more information. Is there now something like is partial or modifiers or something?
Is no modifier. Modifiers with modifiers?
Yes.
Modifiers.
And let's check if those modifiers contains. In the meantime, I need to check what these modifiers are. I haven't had a look at this in the syntax token list, and I assume these are syntax tokens, and these are So we could check if this has a there's a syntax token list, and the syntax token list is syntax token. So we should be able to ask, I think there is an yeah, I think there is I need to check something real quick. There's an overload. Yeah, there's an overload. There's an overload that's called any. So if we use any instead,
Any.
we can ask if any of these is the syntax kind dot partial keyword.
Syntax kind. Oh my goodness. Dot. Oh my god, there's so many. Okay, I'm just gonna get one. And then dot partial keyword. Easy.
Cool. And if that's, we return true, otherwise we go false.
So
we only filter, we only get class declarations that are partial.
Oops. Oh my goodness. True. And then return false is here. Okay.
Yep. Cool. And well, we can do some refactoring later.
Yeah. Wait, there's some.
And now for
IDE can do it
these,
for us.
let's leave it for now. Maybe we need to debug it, and so it's easier. But yeah, let's write it. Let's write it how we feel first, and then maybe because we maybe need to change it. And on the transform, now we want to transform this information to something that we need for our generator, because in this context, we now also have the target symbol. And we could, for example, ask this target symbols, I think for members, or we need to check what type it is. But we should be able to ask it, for example, for all the properties. So what information do we need? Now we need to think, because we're building up our pipeline, what information do we need for our generator? Our generator code needs actually the namespace that this type is in. Actually forgot this as well. This needs to be in the our namespace. We need to do this above. We only generated once, yes. So we need the namespace name.
Yeah.
We already know it's partial, so we need whether it's a class or struct. We need the name of the type. And we need a collection of type and names that we use to generate this. So we need, and this actually,
wait, where do we find out whether this attribute is our attribute? Did I miss that?
Yes, this is what this from attributive metadata name is doing for us.
Got it.
That's the shortcut that's helping us tremendously. If we wouldn't have that, we would need to do this in this transform now to check, to not only extract the attribute here, but also then no, even not extracting, but returning here if we find that attribute that could match, and then actually semantically matching is indeed that attribute, because it could be, I could write this attribute in different names. So technically, so now let's create a type that we're gonna use later on. Sealed record class. Let's just do a sealed class. Let's call this deconstruct info.
Yes.
Construct info now consists of all the stuff that we need. So we need the namespace. Being a bit fancy here, I'm creating required. Wait a minute. Oh, init only. We are in a generator. We're in a .NET Standard 2.0 project. So we would need some polyfilling in order to allow this feature to work. But this is external. I forgot how this is called. Let's use Polysharp. No, actually, I want to create it myself, because a generator shouldn't have too many dependencies. Well, if it's a compile time dependency, that's fine. Never mind. Polish up.
Yep.
Because Polish up will generate this for us, which is again a generator. And yeah, this is what I wanted to look at, that it's indeed private assets all, because project that consuming our generator shouldn't transitively depend on this generator as well. And now this works, because Polish up now is, again, that's a source generator that creates this isExternal init type for us. There it is. And since we now have this isExternal type available, we can have init-only properties. So we use generators to create generators. What else do we need? Name, we need, I don't know, class, well, let's say the type. Then we have the name. What else did we take a look at? And then the pair of, then we have a collection. So let's do maybe an array of another type, which would then be the deconstruct, or let's call it property info. The property info is a string type and a string name. And this will be then an array of this property info, and we call this properties. So now let's here in this transform phase create deconstruct infos out of there. So the thing is now, in context, I know there's a lot. We have the target node, which is the class in our case, but also the target symbol. I think we should be able to cast this target symbol to or check if it is a class, or is this a named type symbol, I think is the correct. I'm not entirely certain, but yeah, we'll find out if it crashes. So we could again check, is the context dot type symbol, is this indeed a name type symbol? And if it is, can we ask the symbol for members or properties or something like that?
Member names.
Do we perhaps also have properties?
Let's see. Oops. No, I don't think so. But it just closes on me the thing. Maybe you try.
No, I would suppose. So perhaps we need
get
to
members.
Ask get.
No.
Yes, I suppose. So we can get all the, because those are just the member names. So let's get all the members.
Oops. Get members. Yes.
Shah was asking whether this type that we created shouldn't be a record instead for the equalability for the pipeline, because the pipeline is using caching. Yes, indeed. We need that later. Yes, I want to build that later to show how to. We do it wrong first.
Okay.
Yes. Memorization.
Way ahead of us.
Oh yes, well, it's not his first rodeo. It's not his first rodeo. And now let's select from these members only properties. So maybe let's do a little linking.
Woohoo! So can we do select?
Let's do a where.
Oh,
sorry, I was using the wrong.
Yeah.
Filter.
That was unintentional.
Okay. So only those that are public. Well, I don't think we care about accessibility, because if we create it within the type, we also know private members, so that should be fine. But maybe is there something like is property or something? Or can we? Oh, can we ask it if the symbol is a property symbol?
Oops.
I'm not sure if there is an I property symbol. Yes, there is.
What?
So let's check if this instance is of type I property symbol. So do a
containing symbol.
No.
No.
Let's do a type check
No.
there as well, just as we do up here.
Where? I'm looking at my. Oh no, I should have looked at the stream.
So
not at my
yeah,
reader.
just as we do above, we do a type pattern matching.
Uh-huh.
We just need the same here again and ask if this symbol, because this M, that's an I symbol. Let's ask if this is of type I property symbol.
Like this?
Mm-hmm.
Property symbol.
Mm-hmm. And if it is now in the select,
yeah,
we can now cast it to that and ask it for its name and its type.
Uh-huh. So wait, do I need to just like as above also call it something, or is this?
No, because we're now in this, we're now in link. So we have the where first, and then let's do the transform, so the select.
Select. Okay, got it.
And well, we can now safely cast this because we did the check first. We can now safely cast this to a property symbol.
Mm-hmm. Mm-hmm. Oh my god, I'm nervous. Property symbol.
Oh, I property symbol. Yeah.
Yes.
Just adding here the
symbol. No.
Like the M here as well. So, and then we have the M. So cool.
Yes.
And we can ask. We can return. We want to convert this. Maybe I'll transform this to a statement, because from here we now want to return this property info.
Mm-hmm.
So let's return a new property info that now has both the type and the name.
Yep. Wait, I'm confused now.
So I'm just doing here. So we have here a property.
Yep.
And now this property should have something like a type name and a name.
Yeah.
Name.
Okay, good.
Let's see how wrong I am.
Type. Dot name.
Let's try that. Yeah.
Done.
There may be a bit nuance to that.
Oops.
Type name, aliases and such, but we'll come to that. Add a property name. Cool. But we need more. That's just a property info, actually. So we now have all the properties.
Yeah.
But we want to return the deconstructor info, actually. So we return a new deconstructor info, initialize it with all the, where the properties are just one part of it. So we can say properties.toArray.
Mm-hmm.
But we also need the namespace, which should be on this I-named type symbol, I hope.
I-named type symbol. Okay. Yes. Oh, I didn't do that. I swear.
I think that's cool.
Was it good? Okay, back.
The namespace, yes, because it's the namespace that this is contained in.
Nice. Let's try this again. No.
We need the type name. So it should be something like symbol.type.
Type.
Does it?
Yeah. It has type arguments, type parameters, base type, is type, type kind, get type.
Yeah, but that get type is from reflection. We don't want to use that. Wait a minute. Do we have it's an I-named type symbol. So this should have, it's the I-named type symbol. So that's the type. So we only say name here. That's my bad.
What? Sorry, I'm confused.
Symbol.name.
Oh, okay. Oops. Yep. And then what's the name?
It was the name, because that's now the name of the... No, I'm confusing myself. I'm actually not entirely certain. Let's debug into that. But yeah, let's see where I'm wrong. I just do something to do here because I'm not entirely certain. Let's come back to that.
Yeah.
Now, I don't think there is nothing. Now what we could do is, because we really build up our pipeline, now we could do more of this pipeline. For example, we could combine this pipeline with other providers. We are only using the syntax provider here. We could, for example, if we need if we want to combine this for some reason with the additional text provider. So because there is also the context.additional text provider, if we want to combine our syntax provider with that one and then combine this information together to create a more meaningful output, we would combine these. We could also add something like a tracking name that helps with when you build your own custom tooling with debugging. We can also do some filtering there, and maybe we want to apply this filter because we have a path where we may return null.
Yeah.
So perhaps let's filter out all of the nulls in the next step. This really now is the next step in the pipeline.
Okay. But it's just with dot and another provider? Do I have to go context provider?
No, we can say where, because we're not combining anything with providers.
Oh.
But we are adding another step. We're now adding a filter step.
Okay.
So we can say where. This is now a incremental values provider. So we could now say, just write a lambda.
Any X? What is it? Provider P?
I think source would be more. Could call it source. Okay. Well, wait a minute. Source is the input. That's a predicate. So we have source is correct. Yes. And we could do a null check on this. Cool. And now this would be now our pipeline.
Nice.
And this pipeline, with all its steps, we can now use to generate source output. So we can say, as the context, wait a minute, is this on here? At source, I need to check, forgot, context dot register source output. There's even a difference between source output and implementation output. It depends on how the host of our source generator is implemented. They may be doing something different with implementation source and source output. Originally, that was meant to, the implementation source output was meant to be only used when actually building your project in a .NET build scenario. So when creating a full compilation, but not in your editor when on each and every key press. For the each and every key press experience, this one was that was the original plan. There was a flaw in the design so that it's never really used by any IDE. So technically it doesn't make any difference. But to be more correct, since we want this generate on each and every type kind of experience, we want to use the upper one. And for that, we now provide our pipeline and now have our action where we create the source code, where we have in some context. The context we can use to have the add source again. This is very similar to the add source that we do in the post-initialization phase. But we also have the source, and this source is now the type that we basically created from our pipeline, which is in this case our deconstruct info. If we were to combine this, because we could not combine this with something else, then we would have a tuple of different types here. But in our case, our source here is our deconstruct info. Now we can use that to create our source code. Now, how do we create a source code? Usually you use a so-called indented text writer. Indented text writer.
Okay. No raw string literals.
Well, that may become a little bit more difficult because we also do some for eaches. And such.
Yeah. Fair enough.
But we will have raw string literals. Just doing the boilerplate for the intended text writer, because that requires a text writer and a tab string. And I think the text writer will be a string writer, I suppose. If I remember correctly. And the string writer now creates a string builder internally. Yes, cool.
Okay.
And we can also define our tab. In our case, I believe we assume 4 spaces. Because the cool thing with the indented text writer, you can say indent ++ and --- in order to get this indentation right. And yeah, all we need to do is now basically generate something that looks like
this.
I'm just adding it here as a comment.
Yep.
Then I would like you to fill the gaps a little.
Awesome. All right. So first we need this auto-generated thing.
Mm-hmm.
So you can just go writer. And we don't need to indent it.
Yep.
Oh, new line. Interesting. No, but do we need anything? What do we need? How do I add it now? Can I
Let's
do add line?
White line.
Right line? Oh,
Mm-hmm.
just like console. Easy.
Similar.
Okay. Similar.
Because
and then I can literally just put this in.
Since you mentioned console, if we go to console.out.whiteline, this out stream is also just a text writer, I think. So this is a text writer, and our indented text writer is derived from text writer, but has this indentation as well. So yeah, basically the API is comparable to the console write line.
Nice.
We could also combine it. Well, we could do some raw string literals and also add the nullable enable directly as well if you would like to in one go.
Mm-hmm. Sounds good. How do I do that? Oh my goodness. How is that? Ah, okay. Mm-hmm. Easy. All right. And then we need this bit.
Cool.
Then we need the namespace. So we don't know this. We can't hard code this. We need to get it from the info.
We could technically use some interpolated string here, but or we add it like so. Yeah.
Yeah. Okay. No, you're right.
No, just we could however you prefer. So I'm adding a $sign here so that we can use.
Cool, thank you.
Because we kind of need the namespace and then the namespace that we have, because we still need the keyword namespace. And then the name of the namespace.
And then the name and space. And
this will be in our type called source. There we have now this deconstruct info where we should have everything available like the .namespace that we extracted in the transform phase earlier. And also a semicolon at the end.
Oops. Yep. Yes.
Cool. And then we need, for partial types, we don't necessarily need the accessibility modifier. So we can omit that. We can start with partial.
Okay.
Now
and then
we extracted what type it is, whether it's a class or a struct.
Source type. Yep.
And then the name.
Easy.
Cool. Then we need new braces because we now write the body of this class.
Yep. Yep.
I'm just killing the.
No.
These are now interpolated strings, so I'm doing $$ here.
So
if we use, this is now where interpolated strings come in super handy. Just using these as doubles and singular ones. Wait a minute, I wanted just 2. So we use
this one.
Yes, exactly. Thank you. So our singular braces are still the C# braces, but for double we now have the interpolation.
Awesome.
And now we need, I guess we can just grab this attribute
What? Which attribute? What? Like
I'll placing
this
it in.
bit. Okay,
Very
got
good,
it.
yes. And now it becomes interesting because now we need this method. Well, public void deconstruct, we can assume, but what about these?
These, yeah.
So for these, we now need the
Properties.
Now we need a loop. So what I'm going to do now is just I'll change this from a white line to just a white, and kill everything from here.
Yep.
So we now afterwards can have our loop over our properties and add this out string name as an out type name, comma thing, and we just white to the whiter.
For each, what is it? Property in P in
source.properties.
Oh, yeah.
We should be able to say whiter.white.
No, p.name.
So we first need the out.
First,
so we could also do some string interpolation again. We need the out keyword, we need the type name, and the property name.
Yep. Easy.
Cool. And then we need a semicolon. No, a comma. Because we may have more than one.
Oh,
in
yes.
our argument list.
Here.
But only if it's not the last one.
Oh no. Okay,
so maybe how do we do that?
If
we don't have .NET 9 here, we can't use the index linking here. So since it's array, I'll change this to a regular loop, if you don't mind.
Okay.
Because now we know the index, and we can ask, maybe let's do this at the end. If it is the last index, then if it's not the last index, add a comma, otherwise do not.
Yes. If autocomplete index no is smaller.
Let's give it a try. We have a test that can then confirm it.
Yeah. Then writer.write, comma
space. Yeah, that's excellent. Perfect. Cool. Now we can ask the writer to complete the line dot write. Now we can actually perhaps we do a write line. We need the closing parenthesis of the deconstruct method. And we could technically again do a was string literal, because we're now going into the body. Where we now need again a loop. Okay, let's not do it like this. It's gonna be, let's actually have here the closing one. Then let's add an open parenthesis. We close the parenthesis, and in between we now need the loop. Now actually increasing the indentation level and decreasing it at the end. And now let's here have the loop that again goes through all the properties and adds kind of this.
Oops.
And this should conclude our generator. We may have some bugs here and there, but this should conclude the
basic
work.
Go proper. So wait. You've already pasted it. Great.
So we did name of the property equals to this dot name of the property. Okay. So this is the prop name, this prop name, semicolon.
Okay. But we still need this that we did before with the P, right? No. And then we writer, right? I've got it up just above, but it's actually quite difficult for my brains to grasp it. All right, that's just what we have up there. Is that right? No, it's not, because it's out. We don't need out. We need P name. No.
Yes.
P name is this. Ooh. Dot P name. And
semicolon.
Do we need semicolon? Okay. Good.
Cool.
Okay.
And then we have
difficult.
Our string writer, and I think we should now be able. So if we have our text,
yeah,
I think we should be able to string this. And we also need the hint name. How do we assemble the hint name? We could again ask our source, go for the namespace. We have namespace dot source dot type dot g.cs. And let's see what will happen. I'd be surprised if it goes green immediately, but it shouldn't be all too red. So let's see. This file is not generated because we don't get the... Do we have a different name? Outpost coding. So the name looks all right. No, there is a difference. Oh, dot deconstruct. I forgot this. We actually also do a dot deconstruct here. So I had a mistake in the hint name, because the hint name is also asserted. Which should now conclude that, and now we should go into the diff. Yes. So okay. We start printing. Okay, something is a bit off because we start printing with the indented text writer here. Oh, okay. We can't toString the indented text writer. Perhaps we need to toString the string writer. Maybe that's my bad here. So if we say the string writer.toString, because we actually got the type name printed out, so the text writer doesn't override toString. But I hope that the one does. Okay, cool. So we actually have in the expectation, we expected to have the accessibility modifier as well. We can remove that. We don't expect this.
Yep.
Because in the partial type, we don't need that. We, however, do need whether if it's class or not. So, okay. Oh, we have a mistake here. Let's take a look at the test. We have, this is really cool because it really helps with the diff syntax. What did we expect? What do we actually have? And we can now, this is where the tests are mega helpful. We can now prove this bit by bit. So the type actually, yes, the name is the name, my bad. And the type would be whether if it's a class or a struct. So I'm wondering, struct, if we get this information out of the named type symbol. Value type is value type. Oh, we could say if it's a value type, then it's class. No, then it's struct. Otherwise, it's class. Yes. Well, there is no to do. What about ref structs?
Yep.
But I believe you get the idea of how, whenever you do something with Forceline, there is that the language has so many features. There is more and more that you may want to consider. But yeah. Now let's run the test again and see how far we get. Now we have a yeah, okay, I made a mistake in the hint name because I was using type. This should be name. There we go.
Okay.
Speaking of namespace, there's also a bit of a gotcha with namespace, but we come to that. Okay, we're missing a new space. What else? we have public void deconstruct out. Ooh, yes, there we go. Since we use the type name, which is actually string, but what if it's a
String.
keyword string?
Yep.
There is a way how to, because we just toString the type name in our transform. Yeah, but what if the name is, I don't know, what if it's what if the type name is type,
Yeah.
system.type?
Okay.
Not necessarily, but there's something like so that's the property info. We can't just use the name. There is something like a to display name method. And the to display name method, you can pass in a format. And with this format, you could, for example, say, hey, use this global namespace style, which is actually what we want to use for source generators. So perhaps we want to create our own format. Private static read only I symbol format. No, that was not it. What was the name? Symbol display format. Oops. Where we now pass in for the first, oops, let's call this format or property type format, where we actually include this full namespace information. And then perhaps we want to set even more. This is the type name aliasing that we talked about. And I'm not sure if this format is already, if it's a keyword like string, if it's also too lowering that. Maybe it is already. And it's, no, it doesn't.
No.
So we're still name. So perhaps we want to add more to that. Symbol display type name only. We also want to have the namespace. Is there a way how to use, if it's a, to use the keyword, if there is a keyword? Use special types. Not sure if this is the thing. Let's take a look at it. Uses keywords for predefined types. This is what we want to do. For the miscellaneous options, special types. Because if it's a string, or if it's an int, we want to use the keyword. If it's not, then we want to use the full name that I think we get via that. So we not only get the global namespace identifier, but also the name and the containing type, but also the namespace, so the fully qualified alias name. Okay, so that looks now good. Now we have some spacing issues there. Okay, that's solvable. We guess we did in the loop. So if we change this to a white line, but also we have, this is not indented. So I guess we need to indent this one too. Let's see how far we get. Oh, we're also missing a namespace here. So after the namespace, we need a new line here. Because it really does a character by character check here for the content of the document. And okay, so it seems that you're just missing a closing parenthesis, and this could be it. So let's outdent again and make this turn green. Oh, we're missing a final new line.
Close.
Oh, are we missing this in the test? No, I'm not. No, I think it's the other way around, right? Yeah.
Potentially.
So
Yeah.
I guess we want to, in our test, this is what we expect.
Nice.
And we got a green test.
Woo!
Now let's see this thing in action. So we should now be able to, because this setup also comes with a sample project,
Nice.
which is, it also has some, the sample also has like a text file, which could be, this is because this is actually what you need if you want to, if you have additional files, and additional files are non-C# compiled files, like for example a text file, you don't see them immediately. You need to, in your compilation, say additional files, include them, and only if you do that, now they become available should you have should you use an additional text provider in your pipeline. Now they are available here, and now you could use them. For example, we don't need them, so let's delete them. Cool. And our samples project is actually also including this project as an analyzer. So we should be able to just doing a rebuild. So we should be able to add a new document. We call it our type. Now this our type, let's see if we have our generators namespace available. Haha, because what we see already, if we go to our source generators of our project, which is consuming the generators, we see that the generator is already kicking in. Our generator is creating this attribute from the initialization, from the post-initialization phase. So we can now use this attribute. The thing is, it's a very important step because generators are oblivious. If we have 7 generators in one project, they don't see each other's output. There is no order to them. They all get the same input.
Okay.
The only thing is, if you have something in the post-initialization phase, this becomes visible in later phases. If we would not create, if we would create this attribute just down here, or if we would have a different generator creating this attribute in the non-post-initialization phase, but in the regular execute phase, this attribute would not be available. And this one wouldn't find it because this attribute is semantically not available.
Is this how we're able to use this poly? Because you said we're using source generators to build source generators. What is it?
No, the polyfill is just providing us with the is external init type that we need in order to use the init keyword. Because we are in a .NET Standard project, in a .NET Standard 2.0 project, and this .NET Standard 2.0 project is missing a type called is external init. This type needs to be available so that init-only properties work.
Okay.
So that's not quite related.
Okay.
But it is important. So this is why maybe it's also suggested too. If this was a broadly used generator, we may want to think about shipping this attribute in a separate assembly. But if we generate it within the generator, it must be in the post-initialization phase so that later phases, like this one here, can actually see it. Otherwise, it wouldn't be there because generators are oblivious. One generator cannot depend on the output of another generator. But since we have it, we can actually use it and the generator can see it. And we now do our generated deconstruct attribute. Well, still nothing is happening, isn't it? If we take a look at the output, only our attribute is generated because, well, it's not partial yet. What if we make it partial? Something happened now. And well,
cool.
Now deconstruct method is generated. It's quite empty because we don't have any properties. And this is now where it is, hey, on every key press kind of a thing, because every time I press something, basically we now need to check, okay, well, this is not a property, so our generated code doesn't change. If we now would do a proper property and give this a proper type and name, now suddenly this appears.
Nice.
And we see if I now rename type to type 1, it just takes a bit until the generator regenerates, and now all of this is updated.
Awesome.
And if we add a second attribute, a second property, now it gets added here as well. And we should be very able to now say, var, oops, I guess we need a method. So public static void example. Our type A equals new. And we should now be very able to deconstruct this into, well, string, just call it 1, and string 2 equals A, because we have created this deconstructor. If we remove this attribute,
yeah, it doesn't work.
Now this doesn't, well, it's, yeah, this document disappears and the deconstructor is gone. And if we edit again, and because it's partial, now it gets added again.
Awesome. Woohoo!
Now we
My
still
first
need to.
source generator.
Very good.
Yeah.
Now comes some nice thing, because we mentioned. Thank you. I mentioned a bit fanciness about namespaces. What if this type, because our type is in a namespace. What if we don't put it in the namespace? Then it is in the global namespace. This now will cause problem, because what now gets generated is, or it actually fails. Our generator is now failing. Because what, that's a bit of a thing. If we go to our generator, how can we show this? We have a test. We can show this easily. What if our type here wasn't in any namespace? So let's comment this out. Now let's run this test. Now our generator will fail because it generates invalid C# code. We see invalid operation exception. Invalid source code is generated. Why is that? Now let's also show the power, because we have a test. We can actually do a breakpoint. Mention the namespace. Namespace. What is the namespace if there is no namespace? Well, if we toString it, oh, did I set a breakpoint?
Not sure.
No, I didn't. So it fails. Namespace. There we go. Debug. If we toString this, we get the string angle bracket global namespace angle bracket.
Oh.
And if we now have this as a namespace in our C# code, this is invalid C# code, because identifiers can't have these brackets. So this actually, a lot of generators have this, yeah, it's a bit of a mistake. What you would actually need to do is to check this namespace. Is it the global namespace? If it is the global namespace, then let's say null in our case. Otherwise, we use what we had earlier. We can toString it, or maybe even toDisplay string it. So we would need now to make this namespace nullable. And now we see, okay, now we would need to here act, well, first of all, in the hint name, because we would also produce a hint name that is invalid. So we would need to say, is it in the global namespace? Then, so if this namespace is not null, then only have this portion. If it is, wait a minute. No. If the namespace is null, only have this portion. If it's not null, the full portion, as well as when we create the namespace here, well, in case of this namespace is null here, then don't emit this. Because we would emit namespace,
Yeah.
global namespace. And this is invalid C# code. And therefore, the generator fails because it creates invalid C# code.
Fair enough.
And there are, well, not implementing this now, but this would be something that we need to be mindful of. And the last thing that we would need to be mindful of, I just want to go to the test and bring this back, is we mentioned performance. So the promise is, why do we, because the incremental source generator pipeline, with building up this pipeline, it's a little bit indirect. So we have our pipeline, and then only later on, we always only register source output. We only register stuff. We never really execute stuff. It's now the domain of the host. Whoever's hosting this generator, this plugin, is now executing this generator. Maybe on every key press, maybe on every 5th key press, maybe every 2 seconds. However, not entirely sure how wide is implementing it, but there is some code maybe on every key press after 2 seconds or something. Maybe you have some logic like that. But if we would do that, if we would on every key press run the source generator, and every time generating the same output, because what happens if we go back to our example? And maybe I'm changing something that doesn't really have any impact onto the generated output. Why is this not generated? So because, there we go. Let's include this again. So our generator creates valid C#. We see it's back. What if we were to change something syntactically? Let's say I enter a couple of enters here, or I enter a method, public void my method. Now this my method doesn't have any impact on the generated output, but we would generate it again. And this is what Shahab has noted us. This is very important for incremental generators and their performance to within each and every step of this generator, there's an equality check going on of these types of this data that we pass in between those steps. And if between the steps the data is equal, it stops and uses the output from the previous run. Because it sees if the data is equal. If it's the same as I have previously generated, I can reuse later steps and therefore result in the same output and don't need to generate it again. So doing some short circuiting there. That's the memorization or the caching of the generators. Each and every step can be, well, the first time it must be executed, then it's new. If something has changed, then the step is changed. If it's the same as the previous one, then it has been cached. Or it could also be that a step is removed. If we remove this type, or if we remove this attribute, now in one part of our step, we don't produce anything, and now this step has been removed, and therefore is no longer. So depends now on how this generator driver then is now utilizing this memorization and caching. But currently we are not utilizing it. And we can test this simply by adding a bit of a datetime now to our generator. So let's say here we just add a comment where we add datetime.now. Let's do a UTC now. Let's build our project. Let's jump back to our example. Let's open the generated document again. And we see I'm now adding something totally different. I'm now adding a comment here. And this will change. Adding a comment. A comment is trivia that doesn't have any semantic input on our project, yet we generated this output again.
Yeah.
So we should now optimize our generator to utilize memorization so that this does not happen. And for that, this is why we also created here a custom type. You should never, between those steps, you should never pass in syntactic or symbolic semantic information. One could say, hey, let's pass this class declaration syntax, syntactic information, between the steps. You shouldn't do this because those are difficult to cache.
Okay.
Because we know in Waston everything is immutable, and with every key press we get a new syntax tree, which means every syntax node is different as well. So there is no caching. And this is similar with symbolic or with semantic information, like symbols. So we shouldn't really use any Waslin types between those pipelines. It is recommended to use custom types and then properly implement equality there. So this is now where Shahab's recommendation was, we should consider making this a record. Because records already come with, sealed record class, there we go. Sealed record class already come with this equatability already implemented. What we saw earlier when we put this into SharpLab, our property here. Let me find a namespace. So we get this thing is equatable.
Yep.
And we get a equals over the equals method implemented, which then calls, here we say, okay, there's a null check, and we do some equality contract, and we get the first backing field, and we compare the second backing field against the other, comparing all the backing fields against each other. There's a bit of a problem though with arrays, because what is the equality of arrays? Is it? Do you remember what an array is? Is it a value type or a reference type?
Oh no! Come on. 50-50 chance. Arrays is a.
Are they on the stack or on the heap?
Let me. Don't confuse me. Okay, wait. I've got an array. It's like a set. Means there's a set amount. An array has a certain set. I don't know.
An array is always. An array is always on the an array is always on the heap. Okay. So it's a reference type.
Yeah.
And the default equality by reference type is not by content, but by reference equality. So, because what we want to check is, are they the same content? So what I'm trying to get at is if we go into a run mode here in SharpLab, and let's say I have an int array, array 1. Let's say this one contains a single 1. And let's create an array 2 that creates a single 1. And let's create an array 3 that has a 2 and a 3. Now, what would we expect if we say array 1 equals array 2? What would you expect?
Good question.
Considering the
I would expect,
default reference types are.
I would say
the equality on them
equal.
Yes, indeed. So they are false. Because it's a reference type and per default, and an array is following that, they are compared by reference equality. Those are two different arrays. They have the same content, but they are not the same arrays. Therefore,
that's silly. You could just point to the same thing.
Exactly. And the default equality, what we get, is now basically doing what the record type is generating by default is basically using the default equality comparer dot default dot equals. Wait a minute, I think I need to give this a type int array default equals, and now passing in array 1 and array 2 into that. Putting into the variable v, and if we print that, what am I doing wrong? Cannot be accessed. Oh, int array, my bad. So there we go. So this is basically what the record type is emitting. It's using the default equality comparer for each type. Just call the equals on it. And well, the default equality of arrays is by reference. And what we want to do is actually by content, because we would always have a different array, although it looks the same. And for that, we could use link and link's sequence equal. So there's a sequence equal. So we can say, is array 1 sequence equal to array 2? Now
And
this
it's
is
true. Nice.
Because what sequence equals is doing is, let's go to source.net. We can go to sequence equal, the one on link. Enumerable dot. There we go. So if it can, it checks if the counts are equal. If they have different length, well, then they're definitely different. And then it basically checks each and every item. And well, you also uses the default quality comparer per default. You could also add your custom comparer to this sequence equality overload, and then just compares each and every element against each other. And if there is any one different, false. If there's all the same or all equal, then true. So in our case, we can't, for arrays or for collections, well, so for the strings, we like the default equality comparison. We have all strings, but the array, we have a problem.
Yeah.
So now there's two ways. We either override the equals methods here and basically do our equality here ourselves. Alternatively, and I want to show that, we could also define our own equality comparer. So we could say private sealed class. This would be the property info array equality comparer. We let this derive from equality comparer of type property info array. And we then, this won't have any state, so we could make here a private constructor and then have a static instance. Yes, because we can reuse the equality comparer won't have any state, so we can reuse the same instance, applying the singleton pattern. Let's implement the missing members. We need to get the get hash code and the equals. I don't think we need to. Do we need the get hash? Well, perhaps it's good practice to implement this one as well. So we get into arrays, and what we could do is to return x.sequence equal y. Cool. And now in return, the property info, that's a record, and we are fine by using the default equality comparer for each and every step there. If we weren't, we could pass in the sequence equals also as an overload that I mentioned earlier, where we could, if it loads, cancel.
Wow. Yeah.
I guess it's getting all the link. That's huge. There's a lot of link methods by now. Sequence equal. We could also pass in our custom equality comparer that is used for the sequence equality. But we are fine with the default equality comparer because property info itself is a record type, and we are fine with the string equality comparison by them. For the get hash code, we can use the hash code. How do we get a hash code for an array? I'm never too sure. There is in later versions of .NET, there's a type called hash code, but we don't have that available here. So I'm just going to return. Wondering if writer usually can do that. If we say doesn't writer do this usually? If we were to create a type that is not a record, we call this my type and say I equatable. and wider than generate equality members gives us a, okay, properties get hash code. It just calls get hash code of this array, which is not a hash code of the array. It is also not quite true, there is a type hash code. Then you could use this dot combine something, and then we could iterate for each item and then basically do something like this. But we are in .NET Standard, so we can't quite do that. So I need to go look how to properly implement. Oh, maybe we can ask. Oh, my license has expired. .NET get hash code array. What's a good implementation there? Just starts with something, then just does, and then element for each and every code. Yeah, I'm never too sure there, so I'll just do some. This may not be super good, because what's important for a good hash code is that it has, what's the word? Good distribute, that the values have good distribution, so that they don't have a lot of clashes. But I never really did this. We're always using this type, but we don't have it available. So let's doing this, but this may be not perfect.
Okay.
Just plussing them, maybe start with, I don't know, 1, 2, 3 there. And what did we see in the example? Like using another number multiplied by that. Yeah, I'm not good with hash codes. I'm not sure if this is a good implementation or not. But yeah, the core part is the core part is that we got the equals right here for this thing, and we could now overwrite per each and every step in our pipeline. We can overwrite the equality comparer, because by default it's using the default equality comparer. So we could go ahead, and after this step where we produce this, well, we could think about, do we wanna, because each and every step in here we already do the equality check. So before we do the where, we could say here dot with comparer, and then utilize our property info equality comparer, this instance. And oh, wait a minute. We need we need a equality compare for the entire deconstruct info. My bad. So we need a deconstruct info equality comparer. Sorry, my bad. Because it's not just the array, we need it for the entire thing that contains the array. So this is our deconstruct info. And in here, we now have deconstruct info X and deconstruct info Y. So we now, those are not arrays, basically need to, this is something that Wider may be able to generate for us nicely. So I was hoping. Not quite. Basically check all of these. So we can return x dot namespace equals to y dot namespace x dot type equals to y dot type x dot name equals to y dot name, yes, and property sequence equals yes. There we go.
Easy.
Cool.
Nice.
And now we can use this because the result of this step is a deconstruct info. So we now use this deconstruct info instance Dickerson info equality comparer. We see we may also return null. Therefore, we need to handle null properly as well. So in the case of if x is null, if both are null, do we need to pass in a question mark here to make these question marks? Yes. So if both are null, then we return true. If either is null, we return false. I believe one could write this a little bit nicer. We could say, yeah, something like that. Both are null, they're equal. If either is null, they are not equal. Otherwise, we can compare them member-wise. Okay. Now we have a proper equality comparer that not only compares the members, but also the array in a sequence.
Yep.
And now we should be able to go back. If we build this, now have the nice incrementality. This is now where the incremental part of our generator comes in, so that it only generates new code when it has to. So if we take a look at this generated output and also at our type, now this is when it was generated last. If I'm editing something in the comments, it should stay at 20, 44, 19.
Nice.
I'm saving, nothing is changing. I'm removing this method entirely. I'm saving, give it 5 seconds. Nothing is changing. Removing the namespace here, shouldn't have any impact on the output here. Nothing is changing. What has an input is maybe changing this type here. Let's change this to a bool. Now we need to regenerate. So now it should be not equal. And indeed, we now get new stuff generated, but only if we really have to.
Awesome.
Like, for example, what if we add a new type? Other type. We now should have 2 of these. Oops, can I? Yep. There we go. Now, if we modify one type, this type should change, but not the other. Maybe I just change both of them so that we get a similar timestamp on them. They're both on 40. And if I change now only our type, but not the other type, only the other type should change, but not the other type. And here we have 4550, and this one is still 4540. And this is the crucial part of this incremental source generator, to have them really, really incremental, and to really design the generator in an incremental fashion where we have our various steps. So we have a step here, then we have a where step here, and we could have multiple steps. We combine it with other providers, and each of these steps should be as comparable as possible.
Yeah.
I guess this question now factors in nicely from Tooks 96. How are we doing?
Great. Yeah. No, I'm really proud of what we built today. Mostly you, but I helped.
Well, I was an assistant.
Exactly. Very good assistant. Well done.
But now, yeah, but the devil is now, of course, in the detail. I don't think, we don't handle ref structs.
Yeah, there's a couple of optimizations.
What about fields? Number. They are not generated. What if we have something like this? What if this is an auto property, but so we have here auto prop 1, we have here auto prop 2, because auto properties actually create a backing field. And now we have let's say a read-only property that is only getting this number. We have an int here, which should be part of the deconstruct. One could argue only this free, because here we have a generated backing field. Here we have a generated backing field. This manually created backing field, but this one doesn't have a generated backing field. So this doesn't really have any data. It's just an accessor to this data. We could have many properties. What if I have, I don't know, get 1 and this returns 1? This shouldn't really be part of the deconstructor, or should it? Maybe not. Maybe only the backing fields, be them manually declared or auto-generated. But yeah, depending on the language features, there is syntax and semantics that you may want to think about when building and designing a generator.
Awesome. All right.
Now what is the word? You mentioned this yesterday to me, and I think I learned that anew. Now we are
really?
We are pooped.
What? Did I say that?
Yeah, I believe so. Yes. And I had to look it up because I thought it meant something else.
See, I also teach you things.
Undoubtedly.
No, it's been a lot, but it's been really, really interesting, and it's so cool how actually how quickly when you first mentioned that you wanted to build something like this, I was like, okay, well, this is an entire season, but no, it's actually there's a lot of stuff already there, and I really like also like the template. So there was a lot of stuff already there when we created the solution and everything. So that's really cool. Yeah. But it also helps to have a good assistant, and everything goes a lot faster. For me on my own, this would have been in its own season.
Well, to be fair, it took me quite a while.
Yeah.
To get a hold of, perhaps 1 or 2 years even, to get a hold of incremental generators.
Yeah.
To be fair, and the documentation is not, well, it's a bit of a corner. It's a bit of a niche topic. To be fair, documentation is available, but not all too detailed. It was, I can imagine, it was a bit of a harder episode to digest. Well, we won't be building source generators live, are we?
No, no, probably not.
At least not in the session that we're gonna have in Oslo. Perhaps,
but there will be live coding.
Oh yes,
and it's going to be, I guess, the first time I code in front of a live audience ever. So it should be really fun. I'm pretty sure I'll make some awesome mistakes that I'll remember for the rest of my life.
Well, to be fair, you already are coding live in front of a live audience.
Oh, that's true, live audience, but like people actually watching my fingers. I mean, it won't be watching my fingers, but it will feel like that to me.
Yeah, you could see the facial expression, or perhaps the lack thereof.
yeah.
What is the most amazing part? Fine. What is the most amazing part for me is it's chat messages, some feedback, or in an in-person event, it's the occasional nod.
Oh,
occasional nod makes all the difference.
I bet it does. Yeah, awesome. And we also have, obviously, we have a lovely talk, but we also have loads of really, really cool episodes planned for you this year. We made a little sort of roadmap, and for me, I don't know, I love it. There's loads of different bits and bobs that I've just experiencing for the first time.
Do you want to tease a little what you have planned?
I was just going to tease what we do next episode, because that's going to be
fair. That sounds fair.
Pretty awesome as well. So when is our next episode, and what do we have in store?
So our next episode is on the 27th of February. And we have Jason Bock on our show again. I think he was there 2 years ago. Was it last season, or was it 2 seasons ago? I'm mixing up. It's our 3rd season now already.
Yeah.
And Jason was helping us tremendously with interceptors and source
Yeah, it
generators.
was.
But source generators and interceptors are only one part of the story. With Roslyn, you can also build analyzers, suppressors, code fixers, refactorings, and we're going to take a look at, well, all of them a little bit, but mostly on how to build an analyzer, which is, well, we actually saw an analyzer at the beginning already when we were using an I source generator, and then somewhere in this example it said, yeah, don't use that, use incremental generators, which is produced by an analyzer. So we'll now build a different component. We will start out very simply. Instead of saying incremental generator here, we will say diagnostic analyzer, and then we go from there.
And then we go from there. I'm really excited. I think it's going to be a good episode. So if you're free, come and join us again.
I'm also posting in Jason's YouTube channel because he's also streaming live frequently, mostly on source generators, but also analyzers. Yeah. Well, he has been quite a source of knowledge for me, so I'm super excited to have him back on our show. Cool. Do we have any final last words?
No, I just want to thank everybody who's joined us tonight, especially obviously our regulars, but also anybody who's here for the first time. It's really a pleasure to have you here, and it's so much fun. It's so much fun to do this. I'm really glad to be back.
From my side as well, thank you very much. It's good to be back. And well, we will, in a bit more than a week, we'll be back again.